Get started. I think everybody's back. We ready? All right. My name is Ralph Hood. I'm a program manager in WinSE. I specifically handle all of our security vulnerabilities that we fix in the Windows operating systems. So that's pretty much what we're going to be talking about, is how we handle those start to finish today. So agenda for today, pretty much a high level of our security response process, very high level. Things you should remember. Products that we support, that's somewhat different than products we support for customer hotfixes and other areas. What you can do and your roles to help improve security and security response in our products. Why we take security so seriously here at Microsoft and specifically in the Windows division. And then kind of how the exploit process works from when a patch is released or somebody publicly talks about a vulnerability to when it's actually exploited, and the high level of that. Some links that you can look at internally and externally that kind of explain this process and how it works. And then lastly, questions. But definitely if you've got questions as we go, just throw your hand up and ask the question. That way, if it's easier to answer based on the topic I'm talking about or something like that, I can answer it as we go. So 10,000-foot view of a security vulnerability. We basically have 5-6 high-level steps of a security vulnerability start to finish. So once it's reported to us, we actually own reproducing that vulnerability in-house. So different than a customer hotfix that we may work on where our support organization or CPR will actually repro and debug the bug. With the security vulnerability, when it comes into us, we actually have to reproduce that in-house. We're typically just somebody sending us a report that they think they found a vulnerability, kind of a high-level configuration or how they came across this vulnerability, and then it's our job to actually reproduce that and determine whether it is or isn't a vulnerability within the product team. Of course, then once you've figured out if it's a vulnerability, we fix it, obviously. The next step is we build a package that we're actually going to plan on releasing to the world through Windows Update and the Microsoft.com Download Center. And then thorough testing. I underline thorough because that's obviously one of the biggest time-consuming aspects of fixing a security vulnerability is testing to make sure that we fix the vulnerability, testing that we're not breaking any functionality of the operating system or applications, and ensuring system stability for our customers before we release a security fix. And then documentation. There's a lot of documentation that goes with a security vulnerability. It's not like a normal hotfix where there's just a knowledge base article or some little one-paragraph blurb. There's quite a bit of documentation that goes out, the security bulletin, knowledge base articles. There's like little, what they call mini blurbs, which is a couple line description of the fix that goes out on Windows Update. And then we actually have involvement from both our Security Response Center as well as Dev Test and PM organizations within the product team that validate the technical accuracy of the bulletins and the documentation, as well as ensuring that we're not giving away too much information. We want to explain people how bad the vulnerability is, but we don't actually want to give away enough information that somebody could take what we've told them and write exploit code for it. And then the last thing, obviously, is we release the fix. Releasing a security vulnerability fix is not only the package, but all of that documentation that goes along with it. In addition, there's customer calls that we do to discuss the vulnerabilities, what impact it may have to different organizations. We release it to Windows Update. PSS security, which is the PSS sec alias that's on there, that's actually a dedicated security organization within product support services, and they specifically handle dealing with our premier customers and how they respond and deploy security patches when we release a security update. And then lastly, MBSA, which is the Microsoft Baseline Security Analyzer, which is a tool that we developed, has an XML backend that you can run on your system, and it'll tell you what security fixes you do have on your system, what security fixes you're missing, or if you've got any combination of a security fix that may only have part of the files there or something, to let you know what fixes you need to be totally secure the day we release a security patch. So details to remember about vulnerabilities. We must fix every valid externally reported security vulnerability. This isn't like a customer bug where we can tell the customer we're not going to fix this. We have to fix a vulnerability if it's reported from somebody outside of Microsoft. So we may fix it in a security patch, we may fix it only in a service pack, and we may fix it in the next OS release. But we actually have to fix that vulnerability, because if somebody ever goes out and posts something to a news group that says, hey, I reported this vulnerability to Microsoft 3 years ago, they haven't fixed it, our reputation as a company just totally goes in the toilet at that point. So reproducing a vulnerability. Within 48 hours or 2 business days, however you want to look at it. Most people like to say 48 hours, but it's actually 2 business days. We want to reproduce that vulnerability and get back to the person that reported it to us and tell them either, yes, we've reproduced it, we see what you're seeing, we agree it's a vulnerability, or maybe, yes, we see what you're seeing, but we think it's a bug, and here's why we don't think it's a vulnerability. Or going back to them and saying, you know what, we've spent 2 days, we've tried to reproduce this exactly how you told us, and as of now, we still can't reproduce it. Can you give us any additional details that may help us better reproduce this problem and try and see what you're seeing? So this helps ensure cooperation from us with typically somebody we've dealt with in the past that reports the vulnerability, but a lot of times it's somebody we've never dealt with, and we don't know how quickly they're going to go public with this vulnerability. We don't know how hostile they're going to get. So by getting back to them within a couple days, it shows that we're serious about their vulnerability that they've reported, and we actually want to do something about it and benefit our customers. So kind of building that relationship from the beginning with reproing the vulnerability is key. Something to note here, all communication is filtered. So the Microsoft Security Response Center, which is where the vulnerabilities are reported into the company before they're handed off to myself to then get dev and test involved to actually work on. The Security Response Center is our conduit to the outside. At no time should anybody within Microsoft, if you're not in the Security Response Center, at no time should you actually be talking directly with the person that reported it to us. There's too many ways that your name can end up in a press article, misquoting something or mishandling how we're dealing with the vulnerability. There's too many ways words can get twisted, or a test or a dev or a PM response on how we're fixing something could get twisted. So we always want to make sure that all of our communication goes from us to the Security Response Center, and then they'll communicate that in both a legally accurate way so that we're not risking getting sued later for something, for misstating something, but also making sure that, that it's kind of, I don't want to say a cat and mouse game, but it's definitely, we want to show progress to the person that reported it to us, but we don't want to communicate everything all at once. And then if it's going to take us 3 months to fix that vulnerability, they're wondering, okay, well, you told me 3 months ago, here's what we were doing, and why is it taking you 3 months to do all of that? So sometimes it's just letting them know what's the next step, and then once that's accomplished, letting them know what's the step after that. So again, no communication should be done directly with the finder. That's typically what we call the person that actually reports these to us. So just keep that in mind. So any communication should go. And MSRC, their alias is secure. You can send that from externally to secure@microsoft.com, or internally, and their alias is secure. So like I said at the beginning, we support products that are somewhat different than what we support for customer hotfixes. So this is actually a fairly scary list for a lot of people to look at. So products that we support. So we support Windows Server 2003. Obviously, it's our newest operating system. That includes x86 and 64-bit platforms. It also includes the 64-bit client 2003 release. A lot of people aren't aware that there actually was a 64-bit client that was released at the same time as Server 2003. So that's one of the platforms that we support. It's totally different than XP 64-bit, even though it's called XP 64-bit 2003 edition. It's different code base. And we support the RTM level at this time of Server 2003. One caveat on that is we also do, if we release a security fix and we've got a beta for a service pack out or a beta for a next release of an operating system, we will release beta fixes of security patches to our customers that are running any beta releases in production. So like Service Pack 1 beta for Server 2003, if there's a security patch that we release that's not included in that SP1 beta, we will deliver a beta fix for that security issue just directly to the people running that. It's not something publicly released. Windows XP. Again, we support x86 and 64-bit. We support the RTM or gold release of the product as well as Service Pack 1. Windows 2000, here's the big difference between what we support for hotfixes. So we support Service Pack 2, Service Pack 3, and Service Pack 4. Typically our support policy is current Service Pack and one Service Pack back. So that would be SP3 and SP4. But when we tried to cancel Service Pack 2 support when we released SP4 last summer, we had a lot of customer demand for continuing Service Pack 2 support, and so we reinstated support of Service Pack 2 for security fixes. So that's one thing to remember when you're testing a security fix or dealing with a security fix. You need to ensure that the fix actually works properly on Service Pack 2, Service Pack 3, and Service Pack 4. That also goes to, with all of these, it goes to reproducing the vulnerability as well. I should have mentioned that on the repro slide, but just because something doesn't repro on the latest service pack or the latest build of an internal service pack, it may be reproducible on an older service pack that we still support, and we need to understand that too. So when you're reproducing a vulnerability, say on Windows 2000, if it doesn't repro on SP4, you need to see if it repros on SP3, and if it doesn't, then does it repro on SP2? And if it does repro on an older service pack, we need to try and figure out what happened between those service packs that changed it from not reproing to reproing, because we still have to support those customers. So we may release a security patch and say, this is already fixed in Service Pack 4, but if you're running an older service pack, here's the patch you need to install. NT4 Service Pack 6A is the next platform that we support. We technically don't support SP6 on NT4, although it was only a one bug difference between SP6 and SP6A. So it's SP6A is our baseline. We don't support any other service pack level on NT4. We don't support SP5, SP4, or anything like that. We support server and workstation. Again, workstation support ended last summer, just like SP2 support for Windows 2000, but due to customer demand, we reinstated NT4 Workstation, and that's actually supported until the end of 2004 and possibly beyond based on customer demand for it. Something to note with NT4, we have two code bases for NT4. We have the standard code tree and then we have the Far East code tree. So when NT4 originally shipped, all of the Far East languages were actually built out of a separate code tree. So whenever we do a fix for a security issue, or any bug for that matter, on NT4, it actually requires two check-ins. So two separate trees. They were never merged after the release, so that's something to remember, that just because we fix it on the US source tree, we need to ensure it's fixed on the Far East source tree so that our Far East customers will actually get that fix. And then lastly, the last operating system we support is NT4 Terminal Server Edition. It's a different SKU than NT4, unlike Windows 2000 where Terminal Server is part of Windows 2000. On NT4 it was totally a separate product that was released, I think, about a year and a half after NT4 was released, or a couple years. And for that we support SP6. There was no SP6A for NT4 Terminal Server. And similar to NT4, there's regular and Far East code bases. So it requires two check-ins and requires validating that both the Far East languages as well as the US languages have the fix that they're supposed to have. So that's what we support. So what can you do to help our security response here in the Windows division? Probably the number one thing you can do is find variants. Inevitably, somebody reports a security vulnerability to us, and we fix that. If there's one security vulnerability in a piece of code, there's at least one other somewhere. So our goal is to fix those before somebody else finds them. So anytime you can, if you see a buffer overrun in the code and you've reproduced that, it's been reported to us, look around in similar components or similar areas of the code and see if there are other places where a similar buffer overrun, or the same buffer overrun for that matter. A lot of times code is copied and pasted from one section of the code to the next, and so it's very likely that similar or the exact same vulnerability will exist in another part of the code. A good example that I like to give for that, last year we released an RPC security bulletin. In July it was MS03-026, and it ended up being MS Blaster was the worm that was released for it. The day we released that fix, like 4 hours later, the guy that reported that vulnerability to us reported another RPC vulnerability that we missed. So 2 months later, we released MS-03-039, yet another RPC security bulletin for that second issue. And that just goes to show that had we spent some time, and there's reasons why we didn't. In that case, we knew we were racing the clock against an exploit that would lead to a worm for that vulnerability, so we needed to get a fix out the door. But it's just an example that there was an overflow in RPC. There was another one like 100 lines later in the code that we missed. So finding variants for security vulnerabilities. Expanding test and attack tools. So a lot of times we'll get code from somebody that reports a vulnerability to us to help us reproduce that vulnerability. Look at that source code and see, or if you're developing some kind of test tools to actually reproduce a vulnerability, look and see if there's ways that you can expand that or modify it to either work similarly on other components or to find other flaws within that same component. And a lot of times that can be done without adding a lot of additional overhead to the tools that you're writing. So, and then suggesting similar components. So if you're working on a vulnerability in, say, DNS, and you think, well, I know that that code is very similar to, I'll say WinSE, but obviously I know they're different. If you know that the code's similar with something else in the operating system, suggest to the person that owns testing that component that they look and see if a similar vulnerability exists there. You'd be surprised, like I said, how often somebody will cut and paste code from one component in the operating system to another just to save time, but they're also cutting and pasting vulnerabilities. So don't be afraid to question the fix or the quality of testing that's been done. So when a developer gives you a fix, if you're testing that fix, don't be afraid to question if it's the right fix made. A lot of times there could be a more complete solution to the fix. Instead of doing spot fixes in 10 different places in the code, maybe there's an overall global change that you can make in the code that'll address multiple vulnerabilities in that code base. Or, like I said, questioning the quality of testing that's been done. Whether it's your component or a component that somebody else owns, if you don't think testing has been done to a high quality level, either in testing a private of that fix or testing the actual security patch, raise your hand, ask a question, say, hey, did you test this? Have you thought about testing this? Have you thought about writing a test application to test it in this scenario? Security fixes are the most broadly deployed thing that we release out of this company, and the most quickest deployed, I'm not sure that's good grammar, but the most quickly deployed fixes that we release out of this company. So any problems with quality are magnified hundreds of times with security fixes compared to if the same problem existed with a hot fix or with a service pack. So ask questions. Don't be afraid to question a developer. Don't be afraid to question another tester. Don't be afraid to question anybody about a security fix and why we're doing it the way we're doing it, or why we've only done a certain amount of testing or not done certain testing. Review documentation. Like I said earlier, everybody in the product team, dev, test, and PM, are responsible for reviewing the documentation that goes out with the security bulletin. It has to be technically accurate. Any workarounds that we discuss in the bulletin, blocking certain ports to avoid being exposed for this vulnerability, or changing system configurations to avoid being exposed for vulnerability, anything like that has to be 100% accurate. We cannot afford to say, block this port, and then somebody says, well, if I block that port, it also breaks Kerberos authentication or something like that. We have to be aware of not only what we're stating as being accurate, but that it's not going to break other functionality of the operating system. So documentation, just to go a step further, in the security bulletins that we release, we list all the details about the contents of the package itself. So file versions of all the files in the package, date timestamps of all the files in the package, and that has to be accurate as well. We have tools that will tell you whether you've got a fix on your machine or not. MBSA, Windows Update, they'll tell you if you've got a fix or not. But a lot of big businesses write their own tools in-house that IT administrators run against their servers or against their desktops to detect for unpatched or patched systems, and if we've misrepresented file versions or incorrectly stated date and timestamps in our security bulletins, then they're inaccurately detecting systems in their environment that need or don't need a security patch. So documentation is huge. Stress self-host and broad testing. So Stefan was just here talking to you about self-hosting, running stress against security patches, self-hosting security patches, doing the broad test pass on security patches. We've never released a fix for a security vulnerability that fix for the security vulnerability has caused a problem on a user's machine. However, I think it's 12 times last year we released security fixes that caused problems with users' machines. But it was always because of something else. App compat issues from another fix that was picked up, a regression with another fix that was contained in those binaries. Based on the way we build code here for service packs and for sustaining our products, all of our fixes are cumulative. So if I make a fix 6 months ago in DNS.exe and tomorrow I make a vulnerability fix in DNS.exe, you're going to get the vulnerability fix plus the fix I did 6 months ago plus every fix in between for that binary. And it's always those fixes in between that have caused us problems with security patches that we've released. So the only way you find those are through stress and self-hosting and broad testing and ensuring that just because I've done my full regression passes on DNS.exe doesn't mean that some change in that code doesn't break some third-party app or doesn't break the TCP/IP stack or something like that that's totally unrelated to DNS. Join a quality improvement task force. Right now, with our focus on quality of security patches, there's a lot of different groups forming to look at quality improvements that we can do, from standardizing on package naming to standardizing on installers to coming up with quality plans on how we improve test quality or dev quality of the fixes that we do. So ask around if there's a specific area of quality improvements that interests you. Ask coworkers, ask devs that you're working with, ask the PMs that you're dealing with how you can be involved in helping to improve quality of those specific aspects of our security patches. And then joining the WNT vulns alias. So that's the general blanket alias that we use within the Windows organization for when new vulnerabilities come in. So if our Security Response Center has a new vulnerability report come in that's related to the Windows operating system, it's sent out to the WNT vulns alias. And from there, it's either my job to then look at that and try and figure out who might be the right test owner to reproduce that, or a lot of times somebody will jump on that and say, hey, I recognize this issue, I know it's this guy's component or this person's component, or that's my component, so I'll take ownership of it. But it's also a good way to learn about security and how we're handling things, because it's good to see the different vulnerabilities that come into us, how people respond to them. A lot of times something will come in that some of the experts that have been at the company for quite a long time will say, you know what, that came up 2 years ago, and here's how we responded to it. And they'll give you a full description on why it's not a vulnerability or why we didn't release a security patch for it. So it's a good way to learn just by kind of monitoring what's on that alias, whether you ever have to deal with a security vulnerability that comes through there that directly affects the component you own or not. Why we take security so seriously. I think this is probably the most important slide that I'm going to go over. So security patches cost our customers millions of dollars to deploy. Anytime we release a security patch, especially a critical security patch, critical severity security patches at Microsoft are clearly defined. We have an external website. I think I have a link to it at the end of my slides. Critical means I can worm an exploit for this vulnerability or cause a virus for this vulnerability via an exploit that cause no user interaction. So I send you an email, you open that email, I own your system. By a default configuration, I can exploit this vulnerability and take over your system or get data off your system. That's critical. So when we release a critical security patch out of Microsoft, our customers jump on that. They stop everything they're doing to deploy those fixes in their environment. If we've got customers that are dealing with 100,000 desktops and 25 or 30,000 servers, it costs them hundreds of man hours to deploy that fix. So it very quickly adds up to millions of dollars for a fix. The key here is that so does a re-release of a security patch. If we screw something up with a security patch, we introduce a regression, we cause app compat problems with third-party apps, we impact system performance, and we have to re-release that security patch because of problems that went out with it in the first time, it costs the same amount of money for customers to redeploy that security patch in their environment. And additionally, it costs us our reputation because we didn't get it right the first time. So again, that goes back to question everything. Question why we're doing a fix the way we're doing it. Question the amount of testing that we've done. Question the quality level. Anything you can think of that'll help improve quality of the patches is something that you should question. Securing our customers is priority number one. So this is key. Obviously, customers, they buy our products. That's what makes our money. If we don't secure them and keep their data secure and their environments secure, the features and the flash that we're going to release in our next operating system, they don't care about. Because if we can't keep them secure now, they're not going to buy our next product. They're not going to spend the money with us. They're going to find somebody else that can secure their environment and secure their data properly for the money they spend up front. So mistakes, no matter how small, impact our reputation. So no matter how small of an application we break with a security patch, it impacts our reputation. It's Microsoft screwed up again. A clear example of that, we released a security patch last November that broke a very, very high-end CAD application. It was actually an add-on for a CAD application that I think literally there's like 100 customers on the planet that own this application. We actually broke that application. And we went as far as not only breaking that application, but if you opened a file, and typically the people using this application were designing multi-million-dollar freeways with this application, if you open that file, you lost all of your data in that file. So that's obviously nothing to brag about. The problem there is it's a very small used application. Nobody uses it. We didn't have a copy of it anywhere here in the company. It took us 3 weeks to get a copy of it from the manufacturer after we learned about this problem so we could fix the issue. But finding ways that we can catch stuff like that prior to release, again, it's a small mistake. We've got 50 million people deploying that security patch within the first few months that it's released. If that only affects 100 people, they can still cause enough commotion and enough bad press for us that it impacts our reputation across the board just as badly as if we'd have broken something on everybody's machine that installed that patch. Security patches are deployed faster than anything else we release. Like I said, if we release a critical security vulnerability patch, people will drop everything they're doing to install that patch. Not only that, but with the features with automatic update that we have in Windows 2000 now, we have it in XP and it's in Server 2003. With automatic update, if we release a security patch the middle of that night, the day that we release that security patch, it's automatically either offered to you or, depending on how you've got automatic update configured, it's automatically installed on your system. Service packs are not like that. Companies take 6 months to a year to test and analyze a service pack before deploying it in their environment. Customer hotfixes, those are given to 1 or 2 customers, maybe 3 or 4 customers at most when we do a customer hotfix. Security fixes are typically 10 million downloads of a security patch within like the first 2 weeks that we release a security patch. So it's an order of magnitude of how quickly security patches are released. And problems with security patches are just magnified in the same way. And then, like I mentioned earlier, we're not going to sell the next release. We're not going to sell Longhorn. We're not going to sell whatever comes after Longhorn if customers don't trust us and don't trust the security in the operating system that they've got deployed. Whether that's NT4 or whether that's Server 2003, they're not going to buy or upgrade to the next release if we can't make them secure in their current configuration. So that's part of why it's so important to us. The high level of an exploit process. This slide can actually be argued just about any way that you want to argue it. The catch here is that somebody reporting a vulnerability to us doesn't necessarily result in the next virus or the next worm that's released. Arguably, it's when we release the security patch. That actually starts the clock to an exploit. There have been 2 times in the history of this company that something's been exploited in one of our products prior to us having a fix out on the web. Every other virus or vulnerability, Nimda, Code Red, MyDoom, Slammer, Blaster, all of those, there were fixes available on the web for those vulnerabilities prior to those worms or viruses being released. like I said, twice in the history of the company has there not been a fix available for something that was exploited. And one of those 2 times, it was a single organization that was being exploited for a vulnerability, so it wasn't a global exploit. So the key there is we release a security patch to protect our customers. We give the details about that security vulnerability to a very high level, just so that you understand the importance of deploying that patch, or whether you need it or not in your environment, depending on configuration. But that's the trigger for the person that reported it to us to get their name in lights. They put we acknowledge them in our bulletin. We thank the person for reporting it to us and working with us so that we can protect our customers. But from there, if the person isn't concerned with trustworthy computing, or isn't concerned with how our customers are protected by these patches, their next step is that they actually release what's called sample code. And that's just basically the proof that they actually found the vulnerability. So they tell you, okay, here's how I debugged this binary and overrun this buffer, and I actually figured out, I found this vulnerability and reported it to Microsoft. Well, it doesn't take much then to take that sample code and turn that into exploit code. Just some minor tweaking to actually turn it into exploit code, that this is something that I could send you in an email, or this is something that I could kick off and it would exploit randomly across the internet. And then from there, it kind of takes the next step from the exploit coders to what we're calling worm builders on that slide. And they basically take the exploit code and they say, okay, I'm going to put a payload in this. And so they're either going to open up a backdoor on your system, they're going to launch something to delete files on your system, they're going to send your address book back to them so they can spawn emails to everybody in your address book, any one of a numerous things. But the start to that arguably is when we release the security bulletin. So your question obviously is, why do we release the security bulletin then? Well, there's 2 reasons. Typically, we release the security bulletin because we know that an exploit for that is imminent. My example of the RPC bulletin we did last summer, we knew that there was exploit code going around on the web between various security groups and hacking groups that we knew would eventually turn into an exploit, so we needed to get a fix out. The other side to that is that these guys that report the stuff to us, if they don't get credit from us, they're going to go public with these vulnerabilities anyway. There are probably 20% of the vulnerability reporters that we deal with that will actually work with us and don't ever care if they get their name in lights as long as we fix the vulnerability. So in those cases, we may fix something in a service pack or in the next OS release. And the person will see, we'll send them a beta copy of a service pack or of an OS, and they can see that we've actually fixed the vulnerability, and they'll just go back to their daily work. But for the guys that are trying to make money off of this, they want to get their name in lights. So that's either by us acknowledging them in a security bulletin, or that's by them going public with something and say, hey, look at the vulnerability I found in a Microsoft product. But I think the key there is that it's not these vulnerabilities coming into us that results in the next exploit. It's typically us releasing the bulletin that kind of starts that train. So again, that gets back to, if we screw up a patch and it starts that train moving towards an exploit for something, and we've messed something up in that patch and people aren't deploying the patch, that's that many more of our customers that are exposed to a vulnerability and to losing data or losing personal information or anything based on the exploit for that. And then there's just columns there that you can see what we're actually doing as a company and what we expect the results to be for each of those categories from start to finish. Links that you can go to. So the Protect Your PC link at the top, this is kind of the link. We launched this last fall, actually right after Blaster hit, and this is the link that you can go to. Running this tool off of the Protect Your PC site will do system changes like enabling internet connection firewall if you're running XP. It'll also tell you what security fixes you need on your system based on what you're running. So it's kind of a combination of running like a detection tool for what you have installed or don't have installed, but it's also it'll enable things like ICF to actually help protect you against certain classes of vulnerabilities. The security vulnerability rating system, so I talked about this earlier. This is where we actually, when we release a security bulletin and we say this is critical or this is important or it's moderate or it's low, that's our 4 classes for vulnerabilities. This website that's publicly posted, anybody can go look at it, will tell you what that classification means. So like I said, critical means I can exploit you without interaction. And I can do that. I can worm that or turn it into a virus. So it can be mass launched. It's not like I send it to one person and I've exploited them. So it's definitely good to read, because another thing when you go looking at documentation for a security bulletin, question the severity rating. Maybe something's rated too low and you know information that makes it worse than we've actually rated it. Or maybe something's rated critical, but you disagree and you think it should be important or moderate in severity rating. So again, question severity ratings. Security bulletin changes. So in October of last year, we made some changes. We went from releasing security bulletins every week of the month. We actually were releasing security bulletins every Wednesday. We actually went to a monthly security bulletin release. So we only release security bulletins on the second Tuesday of every month now. Obviously there are exceptions. If there's an exploit in the wild for something and people are being actively exploited for a vulnerability, we will release a patch at any time. But for the normal business, we'll release patches once a month. But we've had clear customer demand based on the dollars that it costs to deploy a security patch, that it randomizes a customer too much. If today we release a patch for a security vulnerability, they start deploying that in their organization, and then next week we release another patch. And they've got to decide then, well, do I finish the one I started last week, or do I stop what I'm doing and go back to the beginning and start deploying this second one as well as the first one to systems that didn't get it. So it's too randomizing for customers. So the feedback was that a monthly security release was kind of a good happy medium. So it's not like a quarterly release where it's too spread out, but it's not every week or at any given time. Product life cycles. So the Microsoft.com/lifecycle site, this will tell you what products as a company we support. So not only the Windows operating systems that I went over in detail, but any product. If you're wondering, is Windows 9X or is Office 2000 or Office 4.3 or something like that, any product that you want to know if it's still in support, if it's in support for security fixes, or if it's totally out of support, it's a good life site to go to, or website, not life site, sorry. Patch consistency, like I was talking about for quality improvements, we're actually trying to standardize things with patches. A year ago at this time, virtually every product team within the company released patches with different installers that all had different install switches. They may be named differently. So IT administrators just had a total headache deploying patches in their environment, having to remember what command line switches to use with which packages, etc. So the patch consistency or baseline site that I linked to there is actually a good place to go to and see the improvements and what we're working towards for common installers and switches and things like that. And then the last link is the bulletins that we've released in the past. This is a good place to go to see if something that you've been working on has already released. It's also a good place to go and learn. Read about vulnerabilities that we fixed in the past, things that we've found during different security pushes and incorporated in security releases. But it's definitely educating to see different things you should look for when you're testing or you're reproducing vulnerabilities based on things we fixed in the past. And then that's it. So, are there any questions? Hopefully I didn't talk too fast or anything. Yes?
You were referring to a customer, like a product, CAD product, which had around 100 customers, which encountered a problem due to a fix. Now suppose a company like Bank of America, if it encounters such kind of problem due to a fix, one of its banking applications got down. Okay, so how fast do you respond to them and give them a fix?
Okay, so the question is, when we find a problem with a security patch, if it's for a specific customer, how fast we respond to them. Actually, there's two answers to that question. So if we determine that the issue that, say, Bank of America in your example is having, if that's an issue that isn't going to affect just them, we'll actually re-release that security patch. Depending on what the bug is and how hard it is to fix and what testing is involved in testing that fix, we'll kind of determine how quickly we'll re-release it. But typically it's within, I'd say, a week or 2 weeks at most. If you go to the bulletins release website, you can actually, when you look at a bulletin, at the very bottom it gives you revision information. And that revision information will tell you if we've had to make updates to the text in the bulletin itself, or if we've done updates to the packages and had to re-release them for a certain reason. So typically it's a week or 2 weeks. The second answer to that question is, if we look at Bank of America's issue, for example, and we decide, all right, they're the only people on the planet, or maybe them and somebody else are going to be the only people that actually are affected by this issue, we won't necessarily re-release that security fix and cause the entire world to reinstall that security fix. We'll actually do a hotfix for that customer to address that issue. And in that case, it becomes a normal customer hotfix that we do, and depending on priority determines how quickly we turn that around and get it to them. So priority 1 hotfix, we usually have turnaround within 7 days that they have a fix that they can deploy on their machines. So, any other questions? Sure.
MACAS is responsible only for Windows operating system security patches, or for all Windows products?
So the question is MSRC? Is that what you're asking? So is MSRC right? So the question was, is MSRC responsible only for Windows vulnerabilities? So MSRC is actually the central hub for all vulnerabilities coming into Microsoft. There's a person in my position and all of the major product teams across the company that do exactly what I do for the various products. So IIS has a security PM that does what I do. Office does. There are some small product groups like Microsoft Picture It or something like that may not have a dedicated person because they're only going to have a vulnerability to work on once every 5 years or something like that. In those cases, typically then a larger product team will work with them to go through the process. But generally, the MSRC is the hub into the company. They're our conduit out to the people that reported things, and they're the conduit from the outside in to the company for vulnerabilities. But there are people then in all the various product groups that do what I do. Does that answer your question? Okay. Any other questions?
Yeah, I have.
Oh, okay.
I read so many times the security bulletins, maximum are buffer overrun flow. I think 2 years back or 1.5 years back, Microsoft had done some exercise on code reviews thoroughly. How does that help to resolve such type of issues?
That's a good question. So the question was, we do a lot of fixes for buffer overflows, but 2 years ago, Microsoft as a company did a big security audit or security push to identify security vulnerabilities like this and fix them, and how does that impact the vulnerabilities that we address. It's actually a good misconception that a lot of people have. So when we did the security push 2 years ago, that was done on what was Windows Server 2003 prior to when it released. So that was a pre-release operating system. They did a 3-month, almost 3 months, it was about 2.5 month code scrub of all the components in the operating system. We took a subset of the most severe vulnerabilities that were fixed in Windows Server 2003 during that time and backported those to XP and Windows 2000. Primarily it was done on that basis due to needing to limit the amount of code churn that we were taking into a service pack of an already released operating system. If you go out and you look at security bulletins we've released, though, and you look at the number of bulletins released since Server 2003 shipped versus the number of bulletins the first year after XP or Windows 2000 released, you'll see that there's a drastically smaller number of bulletins for Server 2003. And we believe that's a direct result of the security push and security audit work that we did. Even to this day, you'll see a lot of bulletins that we release that don't apply to Server 2003. And part of that is due to those security pushes and security audits, as well as some of the global changes that we put into the operating system during those response times to try and improve security of the product. So, and a lot of that is, it's just going to take us time. The stuff we did 2 years ago, we're starting to see the results of. The stuff we're doing now, we'll see the results of in Longhorn and beyond. Stuff like we're doing for XPSP2 and like enabling internet connection firewall by default and other global changes to protect you from classes of vulnerability are things that we're going to see the benefits long term. It's not something we're going to see tomorrow. So, yeah.
Do you carry out bug analysis for MSRC bugs? And if yes, how do you come out with test plans to take care of security issues?
So the question is, do we carry out bug analysis of MSRC vulnerabilities, and how do we develop test plans for those? So If the question is directed specifically, at me, I don't, because I'm a PM, and you wouldn't want me actually coming up with test plans for you guys. But definitely, we do a thorough analysis of vulnerabilities that come in. There's actually documentation that is required along the way during our process of releasing a security bulletin. And initially, that's what is this repro on? It's kind of just a document that you have to fill out to show what platforms it reproed on. The next document that's actually required is the details around the vulnerability. So what's the vulnerability? What are workarounds? What's the fix? Any mitigating factors? But it also goes into then, has this component been through a security push in the past? If so, why wasn't this found in the security push? As well as coming up with test areas or test cases, things to focus on to find similar vulnerabilities to this in other areas and to also test for this vulnerability down the road. So there's definitely a lot of analysis that goes on both within Windows as well as inside of our security business unit. That's a separate kind of security team within Microsoft that'll actually do analysis on these vulnerabilities. So we come up with test analysis and test plans to test for vulnerabilities and similarities, but there are also other teams that look at root cause of how did this vulnerability get in the operating system, how come it took us so long to find and address, and how can we improve on that in the future. Any other questions?
Yeah. If suppose a third-party product installed on Windows operating system allows our attacker to compromise with the system. Now, how do you pursue with the third-party company in order to fix that particular problem?
So the question is, if a third-party application actually exposes you to a vulnerability or opens you up to compromise your system, how do we deal with that? A common example of that is like an antivirus program or something that runs on your system all the time that may run in like a system level or administrator level context. Obviously, there are times where we may implement a fix that globally will protect you from any application allowing access to the system that way. We did a bulletin for a class of vulnerabilities called the shatter attacks last year, which actually was being able to exploit windows that weren't actually displayed on your desktop. So like a lot of antivirus programs to actually run in your system tray or to do their real-time monitoring will actually run in kind of the background of your system, but they actually run in a hidden window. And so you could actually exploit the system through controls of this window based on the window properties for it. And even though you can't see that window on your desktop or close it, it could be exploited. So there's two things we do in that case. So we deal directly with the third-party vendor, the antivirus vendor or the application vendor, to actually address the problem with their software to ensure that they're developing software correctly and using our APIs correctly. But secondly, if we can do things like block any execution path of any application trying to exploit these hidden windows or things like that we can do on a global basis in the operating system, we'll fix that as well. So we try and hit it from both sides. If there's things we can do with the operating system, we'll do that, but also we'll work with the third-party vendor to make sure that they develop software correctly and that they're not exposing us to vulnerabilities. Any other questions? Okay, with that I think we'll be finished.